first of all, I would like to thank you for the invitation to share some of the information on the present-day crustal deformation of Java, Indonesia, based on GPS data. And I will share some of the challenges, and in addition to that, I will also show some opportunities for research activities in Java. And okay. Is my slide already presented? Can you see my slide?
Yep, your slides look great, Endra.
Okay, thank you. So I will move to the next slide. Okay, first of all, I will talk about the introduction. And well, I believe all of us knew that this is the present-day tectonic setting. This figure taken from Argus et al. In 2011. And if UK probably here, Indonesia is here. Most of you who don't know, we are located north part of Australia. And we have many islands spread from the most western part is Sumatra. And in here we have India plate. And then according to Argus, some small plate or Burma plate here. And Java is actually located here. And the eastern part, there are some microplate, small plate, and this is Sulawesi Island. And in here we have Molucca Sea plate and Banda Sea plate, and also Timor plate here in the southern part. But in the most east part, this is Papua Island. We have Birdhead plate, and in the slightly to the north is Caroline plate and Maoke plate. So we have, as we can see here, the eastern part is more tectonically active. But in the west, we have only India and Australia and Sunda itself. And if we look at the earthquake that happened between 1900 to 2021, based on USGS catalog, for example, for earthquake with magnitude more than 7, we can see that probably most of you knew that the 2004 Sumatra Andaman earthquake epicenter location was here in the most slightly west of the Aceh province. And during those time, we have 2005 Nias earthquake, and then 2010 Mentawai Bengkulu earthquake in 2007 also. But as I mentioned earlier, the eastern part is basically more active than the west. But what interesting is that if we look at in Java here, this is the Java Trench, the subduction zone, and it seems that the current, based on this data, the earthquake is not as much as in Sumatra. And for the next, I will show some identified inland faults in Java, and this is the earthquake that have been investigated by the modern tools. For example, INSAR, GPS, and then seismic. So INSAR, and this was taken from my paper earlier this year. And apart from the 2006 Yogyakarta earthquake that happened here, then basically there were no investigated earthquake based on the using modern technique. And compared to, for example, Sumatra, there was a 2016 earthquake with magnitude 6.5, and it's well investigated. And Lombok, for example, in 2018, and the last Palu earthquake in 2018 that creating liquefaction, massive liquefaction, also draw some attention for research around the globe. But if we look at Java, basically we don't have significant earthquake that investigated by those modern tools, at least during the last decade. And okay, but if we look at the earlier publication, for example, in Simanjuntak in 1993, they proposed that there was a Baribis Kendeng Thrust fault delineated in the northern part of Java. So this is if this is Java Island, and this is Sumatra, and this is Bali, and Jakarta is located here. And there are, in this northern part of Java, 3 main cities. In middle is Semarang, and here is Surabaya. And according to Simanjuntak, this Baribis is crossing those 3 big cities. And this is a very nice publication by Kaulali in 2017. They show some deformation using GPS data. So this is the GPS data that currently maintained and observed by the BIG, or in English we call it Geospatial Information Agency of Indonesia. And if we look at this time frame of those available GPS sites, the earliest site based on this publication was exist in end of 1990s, for example. Although earlier publication suggests that early 1990 they have already installed, but in here they show that in end of 1990s, it's only 1 in here. And through in 2002, for example, at least 2 GPS sites located here. Later in 2008, for example, in here from the green and the blue color, it exists in the most certain part of West Java. And starting from 2011, it's getting much dense, located in here. And this is only in western part, but later if we look at here, the red one here, the red arrow here is using by Kaulali in 2017. So basically, right now we have this GPS station available in Indonesia. And using those GPS data, they publish block modeling and suggest the slip rate of Baribis Kendeng fault here. So their proposal, the slip rate suggests that it's about 2 or 3 millimeter per year. But if we look at the tectonic setting, detailed tectonic setting in Java itself, they don't really show the slip rate of Sesat Cimandiri fault located here. And one thing that we need to consider is the challenge number 1 is that how about the segmentation of this Baribis fault here, located here? Because if we look at the fault itself, for example, in Sumatra, even though it's a longer fault, but it consists of segmentation. And if in 2019, we use the same data and using a different approach by doing a strain analysis, and we managed to identify some high value of strain here, dilatation rate for Cimandiri, and also some portion of large strain in southern Jakarta. And what is interesting is that we also managed to identify a new fault, what we called Cipamingkis fault. And when this paper submitted in the first draft, this seismicity was not yet, the earthquake was not yet occurred. And during review process, then we experienced some earthquake, and then we add this figure earthquake information to support this Cipamingkis fault. So basically, we just lucky that there was some earthquake to support this strain analysis for what we call now Chipamidis fault. But of course, the detail of the geological evidence, the detail of the fault trace need to be investigated. And in 2017, the Indonesian consortium of earthquake, national consortium of earthquake, or we call it PUSCEN, Pusat Studi Gempa Nasional, or National Center Earthquake Center, National Earthquake Center. We published that this book, map of source and earthquake hazard Indonesia in 2017. And inside this book, some information on the Baribis conduct was shown. As we can see here, the Baribis conduct segmented in here, and also some Cimandiri, but not some Baribis conduct throughout or delineated in the southern part of Jakarta. And if we look at those two information, one from geodata and one from the currently investigated geological evidence, then it's become an opportunity, a research opportunity. And how about the detailed work of Cimandiri slip rate, for example, in here, because in here the previous geodetic data has never published the slip rate. And how about the Jakarta fault slip rate also in here? We don't really know. And if we look at the, this is the 3 GPS site here, and this is the Jakarta city, basically Jakarta greater city. And if you land to Jakarta, probably this is the airport here. This is the airport, so this is. And in 2019, for example, the BMKG, or the Agency for Meteorology and Climatology and Geophysics of Indonesia, they recorded an earthquake with magnitude 3.0. The location is in here. It's really small, but this is one of the evidence that it was recorded by the agency. And earlier this year, January 2021, another earthquake with smaller magnitude, much smaller, with 2.4, recorded in probably in the similar location. It's not available in the system, I reckon, because of the smaller magnitude, but it's available through the conversation or the reporting agency of newspaper, this one, tempo.co. So there was a 2.4 earthquake happened here in south of slightly southern part of Jakarta, or west or eastern part, southeast part. Now that is about Jakarta, and if we look at, so the red color is the fault from the PUSCEN, as I mentioned earlier, the National Consortium, and this is also true Semarang City, and this is the airport. So the red color is the fault itself. And if we took the distance, for example, this is the fault, less than 1 kilometer with the airport, international airport. And if we look at here, all of those, this is a very dense populated area. In fact, the fault is located close to the governor office of Central Java province. So this is the governor office, and it's going through the east and still high populated. So in this particular region, the Baribis Kendeng, if we are to use the fault from the PUSCEN 2017, it is crossing the high populated region in Semarang City. And to the east, if we look at the Surabaya city, for example, Surabaya is capital city of East Java, and this is the fault. This is the governor office, and it's still crossing the highly dense populated area. Right, so if we took the distance between the office and the fault is probably about 3 kilometers the distance. Okay, so now if we from those information that the Bari Biskandang through the Semarang city and Surabaya city, and then we need to know, basically it's one of the second challenge that I will deliver today about the tail fault slip rate and the locking depth of the fault itself. So, but of course, in every challenge we can draw, we can take some opportunities, research opportunities. So if we knew that there is some question about detail for slip rate and locking depth in this particular region, then we can use dense geodetic network, for example, and joint analysis multi-data, for example, using INSA. So by combining those available information, then we can get reliable information of the fault slip rate in here, locking depth of the Bari Biskandang, and so probably estimate the maximum magnitude of the fault. And another thing, challenge to consider is the community preparedness for the next earthquake occurrences. So we should not just take the information and then stop our research, but instead how we can bring those information for the community. And I take an example of the right now in Lebak village, for example, in Lebak village is in here, Panggarangan is one of the district in here. And this is the result of the tsunami height based on Widiantoro publication in 2020. I will talk about more in later presentation, in later slide. But if from this figure, we can see that this region here, Panggarangan or Sorten Lebak, basically, will according to this scenario, will experience maximum of tsunami height of 20 meters or probably more in this particular region. And with this kind of information, we conduct a capacity building on earthquake and tsunami at Lebak, and we take, or we bring that the community as a subject, not as an object. So here, my contribution is as one of the team itself. So another team that taken part in this capacity building is, for example, from BMKG, Geophysical Agency of Indonesia, and then from BNPB, and then also from UNESCO also. And of course, for my contribution, because I'm involved in the university, I have a student who also bring or trying to learn to the field, and this is my student, and this is the community. So in this capacity building, basically they request us to assist or with our expertise to assist them about the disaster that may happen in the future. There's a tsunami. And what I want to highlight is this figure, it was made by them. It's not made by us. So those villages, they have the strong will to understand that might happen in the future, what happened to their village. So if this is the main road, and this is the inundation tsunami based on BMKG simulation, and we can see this is the main road, and some of the school were covered by some tsunami here. And we also assist them or expert. We also assist them about the, for example, providing information pamphlet or helping with the information for the community on how to act, how to react when a tsunami happen. And of course, we use some example, for example, from Japan, from New Zealand, or from another region that already have this kind of information. But in the end, those kind of pamphlet was chosen based on the specified requirement or needs or understanding by the local community. So we have to make sure that those information, this kind of information, can be taken easily understand by the local people here. So that is another research opportunity. Basically, what I'm showing is that only in Lebak, but how about another region, another capacity building on community for in Semarang, for example, in Surabaya, for example. So that's kind of capacity building in other. Another info is Lembang Fort. Then this is left here. And this is Bandung City. So according to Daryono in 2019, geologically, Lembang Fault have been well investigated. It's about the total about 29 kilometers. It's a left lateral, and the geological slip rate is between 2 to 4 millimeter per year. And this red color, this one is Lembang Fault. And if we look at the distance between the office of governor office of West Java province, for example, it's only about 8 kilometers. And my institution, my university located here, so it's much closer, about probably 6 or 7 distance. And it's really close. Okay, so that's about inland fault in Java. And next, I will share about some offshore fault in Java. Previous slide, I showed some tsunami modeling in certain coast of Java based on Widiantoro et al. 2020. Those tsunami modeling basically obtained from the this couple information here. The red one is the high coupling region, and the green, the blue one is the post-seismic of the 2006 Java tsunami earthquake. So this red color in the west was obtained from the green color GPS site published by Hanifa in 2014. But the eastern part here, the green, the blue arrow, we invert this blue arrow and obtain the coupling region in the subduction zone in Java Trench in the eastern part of Java. And if we overlay those coupling region and the seismicity from the PMKG, we can see some some seismic gap here, and well, most of the high couple, for example, if we look at here, the high coupling region is much larger in the west rather than in the east. And actually, this information brings to another challenge, because some investigation on the subduction zone suggests if we took, for example, Tohoku earthquake in 2011, for example, how about the possibility of high coupling near the trench? Because if we look at here, the data itself, the GPS data is, well, it's have a much longer distance than in the East Java rather than in the western part here. So in 2021, for example, Murakami, they simulate that, okay, this is the sleep deficit, and if they only use the GPS inland, for example, it's only suggests their modeling is this one, but it's got much better if they have GNSS acoustic located offshore here. And if they use high rate accurate GNSS acoustic here, it's much better, but it will be best if some additional network available. So the bottom line is that if we have a GNSS system to identify the crustal deformation near the source itself, then all the modeling will be much better, and the simulation can be solved, at least for the near trends here. And it's become, in Java, unfortunately, in here, we don't have GNSS acoustic. So we have right now is only a GPS inline in here. So it's another opportunity, research opportunity, if this kind of system is available along the Java trends, for example. And before I show some blue color here, so it was the effect of the 2000 earthquake. So we use Fujisawa model, for example. We analyzed the GPS net exists in 2008, 2006. It's not much. It's less than ideal to understand the whole system mechanism, but at least this green color here, region here, is the tsunami 2006 Java tsunami earthquake, and we're only using what we have available right now. Is only 2 GPS located close to the region here. We managed to extract or to investigate the aftersleep and also the rheological structure, modeling viscoelastic relaxation of the earthquake, 2006 Java earthquake. And of course, these 2 GPS is not ideal, but there is what we have. So at least we are trying to answer our curiosity about how is the seismic deformation of this earthquake. And in 2009, another earthquake happened, called Tasikmalaya earthquake. It's in Trans-Slap, and we managed to identify the fault source. It's dipping to the southwest, and we simulate the tsunami. It's not high, only about 20 centimeters high. And also we explain the aftershock using here. And okay, I will summarize this my talk. There are at first is that more detailed investigation is needed to understand the tectonic sharing in Java, because currently we only knew probably very little about tectonic sharing in Java, and more investigation is needed. And then the second thing is that joint data analysis will be very crucial, because, for example, the limited available GPS data, and right now we have INSAR, and if INSAR can be combined with GPS data, then that will be much more comprehensive analysis we can. And I need to address here that implementing geoscience for communities is very crucial for disaster risk reduction. So we should not stop to sharing, we understand, but then stop. In the end, the communities itself. Earthquake. When earthquake happen, then it will impact the whole system of environment communities. And in my talk, would like to share my Indonesian colleagues that I have write a book, released and published. Okay, so basically that's the end of my slide. So for my Indonesian colleagues, you can get this book in this publishing. It's about eight. If I'm to speak in English, it's only in Indonesian, but if in English, it's about eight steps to write a scientific paper as first author. Some guidance based on my experience. I think that's all my presentation. Thank you very much. I have to apologize for the poor connection that I have.
That's okay. Thank you so much, Endra. That was a really wonderful presentation. I'm actually going to pass back over to Ekbal to do the questions and discussion with you. So Ekbal, do you want to come back in and see if we have some questions for Endra?
Yes, thanks, Tamara. Endra, so I'm hoping you can hear me. So one of the questions earlier on by Ron Harris was on the fault. I think it's called the Barabiri-Kendeng fault, the one that crosses through the three cities. So what sort of evidence did they have for the existence of this fault?
Okay, yeah. So Barabiri-Kendeng, as I mentioned earlier, was first published or was proposed in 1993 by Simanjuntak. So it was 1990 that Barabiri was proposed, and that there were information how about the sleep rate or locking there, because it just derived from the seismic information. But unfortunately, even in the publication, we cannot see clear evidence of the seismic profile in Barabiri-Kendeng in here. But it was one of the earliest publications suggesting that Barabiri-Kendeng exists in the northern part of Java. But then later in 2017, the National Consortium for Earthquake Studies, for example, it was collaborative work, not just from one or two institutions, but more, for example, from academic institutions, from a government agency. They managed to show or to identify the geological evidence of Barabiri-Kendeng, but only from Central Java and up to East. And we cannot, there is no clear evidence in here. And from here, if we look at those two information, for example, from GPS suggesting that some high stream or some slip, if we use COVID-17 fight activities here, then we think that more investigation is needed to understand or to identify the exact location and how is the current fault situation in southern Jakarta. That is because, as that Jakarta right now still capital city. In the next few years, we will move. Capital city will move, but still Jakarta will be the economic supporting economic for the for the whole country, and that is very crucial to identify the babies in this particular region. And it's a lot of approach, geological saying more destined to address or to identify in this region. Hopefully, my answer.
Yeah, I think I understood. I think I heard most of that. Thank you.
Hello everyone. There are some questions posed to me after my presentation. First question is mentioning about if I'm using SAR data for study. And the answer is yes. There are some earthquake events that I'm using joint analysis between SAR data and GPS data. And detail on that will be available through my publication. And the second question, is there any concrete plans for implementing seafloor geodesy offshore Indonesia? As far as my understanding, the current situation right now is some key person in BPPT Indonesia, or in English we call it Agency for the Assessment and Application of Technology. There are some discussion on installing seafloor geodesy into the close to Sunda Strait because the location itself is close to Jakarta Sea. But the tail on that, we shall wait for another publication or information from the key person of BPPT. The third question is, what is the minimum length of time we need from our GPS data to know the value of slip rate? Very interesting question. And if we just want to estimate the slip rate just for the sake of calculation, basically using two observation period of time, we can calculate the slip rate because we can extract the velocity at least from two. Of course, only using two time data in less than 1 year, for example, would create a lot of uncertainties, because what we will try to extract is to estimate the long-term slip rate. And if we're using only less than 1 year, then it could cause a lot of uncertainties. So some publication use more than 3 years data, some are using 5, some using more denser, or some using campaign. It depends on how is the tectonic setting, if the slip rate is big or is it small, close to, for example, 1-2 millimeter per year, or is it larger than that? But in general, some publication, for example, the latest publication of slip rate in Aceh, Sumatra, we use time period of 5 years data to estimate the slip rate. Another question is asking about capacity building for earthquake hazard different for communities living in large cities of Java threatened by inland fault. Yes, it's very interesting that, as I show in my presentation, that in this certain part of Western Java, in Lebak, the community itself is asking for assistance from the experts, such as from BMKG, from BNPB, from academic institution, from ITB, in fact, also from UNESCO. And this kind of level of understanding that their region has a high potential of disaster occurrence in the future is really good, because they know that their region might happen. Not so many regions in Indonesia have this kind of level of understanding. So if we look at these communities, then it's a pleasure to support when they themselves have the willingness to learn and willingness to understand about the potential disaster that may come in the future. The next question is related with the possibility of geodetic data records volcanic deformation. And it has been proven in some scientific publication in many volcanic area that not just GPS data, but also INSAR, for example, both of these space-based geodetic method capable of recording the ongoing surface deformation, which then we can invert into the pressure source beneath the volcano. Hope my short answer could explain some of those questions. Thank you.
We just want to give a huge thank you for presenting for us today. It was a really interesting presentation. Thank you for making the time to come and speak to the community. And do you have any words from Iqbal or Endra?
Yes, Endra. So thank you very much. It's wonderful to hear from you and I think the one thing I took away from this is not only the research you're doing, but also the research opportunities we have to continue to work together. And I suspect many members of COMET will want to think about how we can move together to help you with these research opportunities you've highlighted. So I'm sure we'll stay in touch and we'll continue to be in touch. So looking forward to continuing these conversations. Thank you very much.